Hello everyone and welcome to We Meet at Digital Days. My name is Lisa Richter and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Power Modules, Introduction of New Products. Our speaker is Eva Helmstetter. She will hold a presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out a survey and help us to improve our event. You will receive the link for the presentation in the next few days, and the recording will be available at our website shortly. So now I will hand over to our presenter, Eva, and I wish you a good presentation.
Hi, my name is Eva Helmstetter and I'm the Business Development Manager for Power Modules. And that's the reason I'd like to show you some of our new products today. As you can see, we are in our virtual booth and I'd like to show you our new products. Therefore, I go to the new product area for our optoelectronics modules. As you can see, we share one screen. And if you go into the screen, you can see our micromodules. As you can see in the picture, we have two different types of micromodules. We have the open framed ones and the fully molded ones. But all of them are fully low conducted and radiated EMI compliant to EN 55022 Class B. Because of the LGA6 EP package, we have a very low profile. And because of this very profile and the package, the modules are ideal for space-constrained applications. Examples for those applications are point-of-load DC-DC applications from 5 volts to 3.3 volts, and they are a perfect replacement for linear regulators because they have a very low ripple and they are SMD molded and not through-hole technology molded like the usual linear regulators. Other applications are interfaces and microcontroller supply, battery-powered equipment, and many other applications with small currents and small voltages. If you go to our online catalog, you can see many more information about products. So for example, you can see that our overmolded product is even a little bit smaller than the open framed one. Furthermore, you can already request some samples, for example, and you can see the whole data sheet. And of course, we have for all of our products evaluation boards. So for each micromodule, we have one evaluation board which you can test. It's a little bit easier with evaluation board to do some tests because the modules are so small and a little bit difficult to solder by hand. To show you some more information, I prepared a PowerPoint presentation for you, where I'd like to show you the design step of the micromodules, which features we have, how to use the adaptive switching behavior, and why the modules are flexible through scaling. But let's start with the design steps. As you can see, we have 4 design steps. In the schematic below, you can see which components are needed to implement it. First of all, we have to set our output voltage, of course with a voltage divider, and here we need 2 additional resistors. Next, we have to select our input capacitor and our output capacitor, and at the end, we have to select the feed-forward capacitor. So to sum up, to implement one of our micromodules, you have to add 2 additional resistors and 2 additional capacitors, and then you are done. So it's quite easy to implement them. The first feature I'd like to show you is our enable function. With the enable function, you can turn your module on and off. Because you have a enable voltage, and if your output voltage is higher than the enable voltage, then your module is on. If the output voltage is lower than the enable voltage, then your module turns off. So with the enable function, you have the control over the startup and the shutdown behavior of your module. The next function is our power good function. With power good, you can indicate if your power module is working within the nominal specifications. So that allows, for example, monitoring for diagnostics and signaling. So you can connect, for example, a LED with your power good pin, and if the LED light up green, then everything is fine. And if the LED light up red, for example, then you should have a look to your application, because then the module doesn't work in the nominal specifications. Another application is sequencing. For sequencing, you have to use the enable and the power good function in combination. So in the schematic below, you can see how it works. We connect the enable pin of the second module with the power good pin of the first module, and the enable pin of the third module with the power good pin of the second module. So the second and the third module are supplied by the previous power good signal. And with this combination, all modules start up sequentially one after the other. It works like this. So when the first module reached its nominal specification plus minus 5%, then the second module will start. When the second module will reach the nominal specification plus minus 5%, then the third module starts. Sequencing is quite good because then you always have the same behavior on your PCB. Otherwise, with the first startup, for example, the second one start first, then the first one, and then the third one. And when you turn the module the second time on, then you can have a different sequence. So for example, the third one start first, then the first one, and then the second one. So you don't know how your PCB will react. A second advantage of sequencing is that you have low inrush currents. So it's perfect for applications that are sensible to inrush currents, because you always have just one inrush current at the time, and not all of them together. Of course, we have some protection functions as well. The first protection function is our short circuit protection. Here, the output current is limited during a short circuit condition. So this feature protects the power module from overheating. The overcurrent protection works similar. So here the output current is limited during an overcurrent condition. And again, this protection feature limits an overheating of the power module. If the power module gets too hot, we have our temperature protection. So when the junction temperature for our micromodules, it's 125 degree, exceeds a dangerous limit, then the whole module shuts down. This prevents failures during accidental device overheating. Of course, when the module cools down again, then it gets started again on its own, and everything will work as usual. The last feature is our mode function. With our mode function, you can choose between 2 modes: pulse frequency modulation and force pulse width modulation. With the pulse frequency modulation, you can have a high efficiency and low currents. To use this mode, you have to set the mode pin to a low level. rather have a low ripple in smaller currents, then you can use the force pulse width modulation. For this mode, you have to set the mode pin to a high level. So with the mode pin, you are allowed to tune the module performance based on the application needs. The mode function we need for our adaptive switching behavior. To understand it, you have to know that, of course, we have two loads, a light load and a heavy load. The light load is for applications that works in ideal or standby mode. Here we have a reduced energy consumption. In comparison to that, the heavy load is for application that works under nominal conditions. And of course, we have a nominal energy consumption. Our mode function we need for the light load applications. Why I can show you in the next diagram. As you can see, the red line is for our pulse frequency modulation. The red line is for the forced pulse width modulation. And in this area, so around 100 milliampere, the mode switch is happening. And after 100 milliampere, both lines are similar. Here we are in a heavy load. So in the heavy load, we don't need any switching regulations. But when we look at the currents below 100 milliampere, you can see, for example, at 10 milliampere, we have a difference in efficiency of already 25%. When we check the same thing at 1 milliampere, we have even a difference of 65%. So that's really huge. So as you can see, for lower currents, the pulse frequency modulation is really, really better for a good efficiency. Unfortunately, here we have a disadvantage as well, because with the PFM mode, we have higher ripple than the forced PWM mode. So if you'd like to have a low ripple, you can use the forced PWM mode, so the red line. But if you like to have both advantages, you can use the PFM mode, so the black line for high efficiency, add an additional input-output capacitor, and then you have a lower ripple here as well and have both advantages. As you can see, we have 4 different micromodules in our portfolio at the moment. We have modules from 600 milliampere to 1.2 ampere. So you can choose between a low power density and a high power density. Of course, it depends on the application, what you need. Our 600 milliampere module with mode pin and our 1 ampere module with mode pin are one-to-one pin-to-pin compatible. So that means for you, if you have a project and you'd like to use our 600 milliampere module, and during the development process, you see, oh, 600 milliampere is not enough, I need 1 ampere. It's not a problem at all. You can just switch the modules, don't have to do any layout changes, because as I mentioned, they are pin-to-pin compatible. Furthermore, we have feature options. We have a 1 ampere module with the mode pin, so you can choose between ripple and efficiency, or you can use the 1 ampere module with the power good pin, so you can monitor or have a sequence. All of those 3 modules, so 600 milliampere and both 1 ampere modules, have the same footprint. So you can vary for all 3 of them. Only the 1.2 ampere module has a different footprint. So you have to consider if 1 ampere is enough or if you need 1.2 ampere for your project. Okay, that was everything from my side to the micromodules. If you have now any questions, I'm happy to answer them.
Thank you, Eva, for your interesting presentation. Now we would like to turn to the questions. You can mention them via the chat function in the control panel. So just have a look. Okay, I think there's a first question. Is it possible to use the PFM mode for the 1 ampere PG module 2?
Yeah, sure. So you can choose between the mode module and the power good module, but in the power good module, the switch is happening by itself. So the power good module always will use the better efficiency.
Okay, great. So there's the next one. Are the capacitors you can see on the open frame modules input and output capacitors?
They are partially input and output capacitors. So we included some input and output capacitors that you don't have to use a higher value and, for input and output capacitor on your PCB, but they are not enough. So I really would recommend to use an additional input and output capacitor.
Okay, so let's have a look. There's a next question. If I want to change the output voltage during the operation, can I simply adjust the feedback ratio by switching in another resistor, or does it first have to be switched off and then back on?
I think it first have to be switched off and on, but actually I'm not quite sure. But I will ask our expert, our product manager, and I will come back to you after this ASAP.
Okay, thank you. So we will answer this question afterwards via mail. If there are any other questions left, we will answer them also via email afterwards. And thank you very much for your attention, and I hope you enjoyed our presentation. The next presentation topic is Optoelectronics Introduction of New Products and starts at 11:30. So see you there and enjoy our digital days, and goodbye.
Bye.